So folks, we'd like to get more careful with our area finding function here to make sure we understand. So here we've got this function, and let's go ahead and label this function here shown in blue. This is the function f of t. And our area finding function, this is where you've got to be careful. Notice where the independent variable is. It's the upper limit of integration. And in this case, we start the area finding function at 0. So let's just point out that if I were to ask you what is f of 1, there's the value for f of 1 right here. There's the ordered pair 1, 2. So f of 1 is equal to 2. But that's not what I'm asking you to compute here. I'm asking you to compute a sub 1. And it turns out that a sub 1 is 1. Why is that? Now, to be successful with these problems, folks, what you need to do is you need to first of all write a sub 1, and then take your function for a sub x, which is this function right here, and everywhere you see an x in the function for a sub x, everywhere you see an x, you're going to go ahead and plug in the value 1. And so that's asking you to compute this definite integral right here. Now, if you actually knew the formula for this, and in fact it wouldn't be that hard to come up with, you could come up with a piecewise function that describes f of x. You could go ahead and use what we're about to show with the fundamental theorem of calculus to evaluate this. But all we know right now is that this is asking me to compute the area underneath the curve f of t from 0 to 1. So that is, I'm being asked to find this area right here. And pay attention to these problems, folks, because sometimes you need to work through these through some calculations. But in this case, we're just going to use geometry. Notice that this is a rectangle, or excuse me, this is a triangle whose base is 1 and whose height is 2. And the area of a triangle is just 1/2 its base times its height. And in this case, the base is 1 and the height is 2. And if we compute that, we get 1. So that's why a sub 1 equals 1. Please do not shortcut this middle step, folks. Even if you get the right answer, you're not setting yourself up for success with these problems. So what I'd like you to do is I'd like you to compute a sub 2 and explain why it involves computing the area of a triangle. So pause the video and give that a shot. So now I'd like to go ahead and look at this. This is where I think it's really handy to work these problems in pairs. I'm going to compute f of 3, and then I'm going to compute a sub 3. So if we go to this problem right here, this function, if we go to look at this ordered pair, there's the ordered pair 3, 4. So for our red function, f of t, f of 3 is equal to 4. But completely separate from that, I would like to compute a sub 3. A sub 3 is the area finding function. It's this function right here that uses as an underlying function the graph of f. But we're going to compute the area between the graph of f and the x-axis on the interval from 0 to whatever x is, because that's how the function was given to us. Just one more time, this is the area finding function. A sub x equals the integral from 0 to x of f of t dt. And I'm going to replace the x as the upper limit of integration with whatever I'm evaluating the function at. So in this case, 3. At this point, all you need to do now is compute the area underneath this curve between 0 and 3. So we've already computed this area. We know that's 2. But in fact, we could go ahead and keep going with this. And we're going to compute the area of this. Now, folks, please, we're doing some higher level mathematics at times, but this is just finding an area. And if you think about boxing this up, notice that here I've got a rectangle, and the area of each one of these little squares inside of that rectangle is area 1. So there's 1, 2, 3, 4. And then we can compute the area of this larger triangle right here, which is which has a base of 2 and a height of 4. So the area of this larger triangle is 4 because it's a triangle of base 2 and a height of 4. And if I do 1/2 base times height, I get a total of 4. And I add to it the area of these 4 1-by-1 boxes. And so sure enough, yes, I end up with an area of 8. Please, folks, you need to stop the video and confirm that that area is 8. So now I'd like you to compute f of 4, and then I'd like you to compute a sub 4 by that same reasoning. And go ahead then and finish out the remainder of these problems. and let me know if you have any questions. Folks, if you don't understand how to do these problems, you need to come see me as soon as you can. All right, I'll see you in the next video.